Hello students, in this video we'll see an example of using the central limit theorem to approximate a probability. Let's suppose that U1, U2, U1000 are 1,000 uniformly distributed random variables on the interval 0, 1 that are independent. Let's find the probability for 97 less than or equal to U1 plus U1000 less than or equal to 505. So to do this, we recall what the central limit theorem states. The central limit theorem states that if x1, xn are IID, identically distributed and independent, then x1 plus xn minus n mu, where mu is the common mean, over root n sigma, converges to a normal 0, 1 distribution. That's our central limit theorem. And so we're going to apply this. So I can change this into a central limit theorem problem by taking this random variable on the inside and subtracting off n copies of the mean and dividing by square root of n times the standard deviation. So let's recall that if u is uniform 0, 1, then the mean of mu, the expected value of u, which is mu, will be b minus a over 2, which in this case is just going to be 1/2. And then we know that the variance of u is going to be b minus a squared over 12, which in this case is just going to be 1 over 12. And that tells us that the standard deviation, sigma, is going to be 1 over the square root of 12, which is 1 over 2 square root 3. So we have our common standard deviation, we have our common mean. So now we can subtract off n copies of the mean and root n times the standard deviation in our problem. So what we'll do is our probability can be adjusted because I'll subtract off 1,000 times the mean. So 1,000 times 1/2 is 500. So we'll subtract off 500. So 497 minus 500 is less than or equal to U1 plus U1000 minus 1,000 times 1/2 less than or equal to 505 minus 500. So I've not changed the probability at all. And then the next thing we'll do is we'll divide by the standard deviation. So over here this is a -3. Over here this is a 5. And then I have to divide this whole expression by the square root of 1,000 times the standard deviation, which is going to be a 1 over 2 square root 3. And now the square root of 1,000 is, well, it's 100 times 10, so it's going to be 10 root 10. So this will become a 10 root 10. So we can simplify this as 10 root 10. And then the 2 and the 10 will cancel out and turn to a 5. And so if we simplify this, we'll get the following expression. And we'll have to divide that by everywhere as well. So we'll divide that over here. Divide this by the square root of 1,000 times 1 over 2 square root 3. And divide this by square root of 1,000 times 1 over 2 square root 3. And if we simplify this, we see that it becomes the probability -3 over, I'll have a 5 and then a root 10 over 3, less than or equal to. This whole random variable now is approximately a random variable z, which is normal. So we're going to approximate this with a normal. So this is an approximate probability. Less than or equal to 5 over 5 root 10 over 3. And now we can write this in terms of the CDF of a normal random variable. So what happens is this will simplify a little bit. And so this thing over here is root 3 over 10. So this is going to be phi, the CDF of a normal, standard normal 0, 1 random variable, of the square root of 3 over 10, minus the bottom limit. That's going to be phi of, well, if we simplify this, what will we get? We'll have a 3 root 3 on top and a 5 root 10 at the bottom. So this will be a negative 3 root 3 over 5 root 10. And this is our approximate probability that the sum of these uniform random variables is between 497 and 505. Thank you very much.